Hello again, welcome back. As usual, this is Becca, your coder kitty, often going by Nightcat or Nightcat's Meow Win Online. And welcome back for another week talking Linden scripting language. Alright, I had promised the next steps were to go over a way to filter the people that come from most common to least, and also to get a general gauge of time. These are two a little more precise than they were logged in at so many of the 5-minute chunks. I've got an idea how to do that, but I think the thing that would be more useful in a wide range of applications, not only in this particular one, is going to be to filter and reorder the list. So that's the one that we're going to deal with first. And I remember before there was concern about the script in this, somebody thought that it could lag out and keep you from logging into a place. I've had this thing running constantly since I recorded last week's video, and for those of you that wonder, I am recording this on Monday, so it has been a decent period of time, and it's given me no trouble with logging back in this time. So I think that the concern that my script may have been what knocked me out a couple weeks ago, I'd like to declare that myth busted. So, what we're going to do for this particular bit, we're going to do two things. One is we're actually going to turn off the system that's currently tracking visitation. We're going to actually kill that, and we're going to set up fake data. The reason we're going to kill that is because I don't want to overwrite the existing lists. Actually, I could go ahead and just add to the existing list. I don't have to kill the record keeping, come to think of it. I'm going to add fake data to the list. The reason why we're going to add fake data is I don't have a bunch of people to show up at the sim and go ahead and populate it up to get a large number of records going. So I'm going to create some fake records that I'm going to hard code into here that I can use to then run the filtering part of the algorithm. The other thing we're going to do with it is, because when lists start to get long, if they get really long, they have the potential to run over the allotted memory for a script, and that would give you a stack overflow. That is very unlikely with something like this, as the lists involved don't take up that much memory. But I will show you how to deal with that problem as well. That should pretty much take care of this week, and next week I will go over the better time stamping. So, to do this, we're going to start by adding to the list. Now, everything in the list is treated as a string, or a word or series of letters. So, it has to be put in the quotation mark. So, we're going to start with alright. The first thing I could think of that came with a large number of names. Those of you who can see what I'm doing with that. Yes, I like My Little Pony. Rar. I'm not giving any thought to what the numbers are I'm adding in here. I'm just adding numbers. Kind of semi-random numbers. So I have 1, 2, 3, 4, 5, one more set of numbers, and the one downside is that's going to be a problem because I don't have keys. That is actually going to be a slight problem since I'm making up names. So what I'm going to do is I'm going to add in a nice little catch that will deal with that problem. So when it goes to check, records, check complete. Here we go. That would be the name query. So if visit and check rec visit. Alright. Sorry, I was just reviewing how I had that running. The easiest way to do that is going to be to create check string check equals this piece of code where we pull the specific key for the visitor based on which record we're checking, because we're going to use this in a few different places now, so it's easier to just establish it as a variable inside the confines of this statement. So if, and then we want to have the string length, so we're going to pop in here real quick to our trusty Google search, LSL, whoops, that's typing into world, LSL, get string length, returns in integers the number of characters in string. This is perfect. So we'll copy that. Pop this in. If string length check is greater than 10, then we run the name check query, and all of that proceeds the way it would have before. Otherwise, else, owner say registered visitor, string check rec plus 1 is, we'll replace data with check, and has been logged. All the rest of that can stay the same. So that should be a way to go ahead and make sure that if for our test data that we actually get the correct information. If we had, you're not going to have to worry about that particular check in an actual running program, because any key that it acquires will be more than 10 characters long. It's always going to happen. This is really only necessary for incorporating test data that has to work in a particular way. So okay, and now I actually found a problem with the program that I had not thought of, a small mistake that I made. And that is that it is not going through and running the record check a second time. So that was a mistake I'd made before, something that I only would have found testing it with more than one piece of data, but without somebody else in the sim, then I never had that other piece of data to test it against. So we're making this a full function instead of just the one line. We're actually using the brackets because we're going to have more than one command running. And we're going to tell it to run records again. And before running records, we should actually increment check rec or check record up by 1. So copy. Check record equals check record plus 1. And that is a somewhat inelegant, but it's a way to work it within the data server structure to increment up the record that's being checked. Because if you remember in touch, we start check record at 0 here. So that will automatically always start at the beginning whenever we're running this particular function. But this method will keep looping it back and running it a second time with the new record number. I really should have caught that particular problem the first time, but with only one record to check, I didn't actually see the problem. So that fixes that one problem from before. There we go. So, registered visitor number 1, ping, logged 23 times. That was the first time I ran it. Then running it again, been logged all the way down the list. Another thing that we can do to sort of smooth this out is up here when it declares that it is checking records, we can say if check rec equals 0, then it will say checking records. This means it will only display the checking records on the very first entry. So you get a list that comes out more in the way you, more in the way you would want as a user. Checking visitor records, visitor number 1, 2, so on and so forth. So that patches up a problem with the original version. Actually 2 of them, now that I have enough fake data to actually process the entire thing. And when that's had long enough to add me to the list, it should automatically put me in at number 7 and proceed to run that. So I'm going to put this on pause for a minute while I go ahead and give it time to do that. Okay, welcome back. We've had a moment to make sure that this device actually includes me in its log. And there we are. Rebecca Wendell has been logged 1 time. So we're going to go pop back into the script. Now that we have a way to, we have extra data to work with, we can go through and log this based on frequency of appearance. And the way we're going to have to do this is going to involve creating an entirely new set of lists. So you might wonder, how do we go about creating the new lists? Well, we're going to first establish their existence. List visit ranked equals an empty list. List count ranked equals an empty list. Now that you have your 2 new lists, visit ranked and count ranked, we're going to withhold. We're not going to deal with the records check immediately, but when we do, we're going to run them to visit rank and count ranked. So ranked capital R's Double checking that I'm not. There's the one I was missing. Ranked. Ranked. Now, just to make sure that it's pulling these correctly, we're going to start by creating a function, rank lists. Now, initially, just to make sure that we can test the ability to read the correct lists, we're going to propagate visit ranked and count ranked with the original visit and ranked. All right, it is not reading those, and I actually realized why. Silly me. I ran the ranked lists without actually running those. So touch start. We're not going to run records. We're going to run rank lists. And at the end of those two functions there, then we will check records. There we go. That actually does proceed to read them. Since we got no information from them before, that confirms that it was reading nothing from either. And so you reread it for the second one, and it reads everything correctly. The next step is we're going to start to actually rank these. The way to do that is we're going to need to make a for statement here, a for operation here. For I've done these a few times. Y'all should remember how they work. I is less than all right. So the first one we're going to do is we're initially just going to establish the lists for count. So we're going to leave visit rank equals visit just for convenience. The numbers are going to be all out of place, but it'll be able to confirm that we have them in there correctly. How we're going to do this is it reads the first entry on the list. So integer check equals, cast this as an integer, list to string count, comma, I. If debug, owner say, checking list item string I plus 1, putting this in very human terms, plus equals Since it was cast as an integer, we're going to recast it as a string. All right. So for the rank list, it should go through each of these individually. This is going to give us just complete BS in terms of a final output, but it'll give us a look at what it's doing. Here we go. Checking list item 1 equals 23 equals 5 equals 8, 88, 27, 44. So it is properly checking each of those. So the next thing we're going to do is we're going to compare the entry it's checking versus the entries that are available. So there we are. The way we're going to do that is first we have something for it to compare to. Now, if we put the setup for that inside this for loop, then it'll keep iterating it every time it goes through this loop. We don't want to do that. So we want to put this outside the for loop. We're going to do that with count ranked equals, and we have to make it a list format because that's how it will understand it. List to string count 0. We can also add in visit ranked equals list to string visit 0. Again, putting it inside the brackets because we're establishing this list, or we're saying the list equals this, so we have to treat it as a list even though it only has one entry. The other thing that could possibly be a little bit confusing is that though the counts are all integers, they're all numbers, everything stored in a list, I'll remind you again, is stored as a string, as though it was just letters and words, even if the letters are actually numbers. It's treated as a string of text by the system. So when we need to compare it as a number, we cast it back into an integer here. When we need to leave it in a list, we leave it as a string, like we do up here. It's just a matter of there is sometimes a difference between what we're actually using it as and the kind of information it's stored as, which is why we can cast it as one or the other. So with these, we will automatically put the first entry in place, because when it's the first entry, it's automatically going to be number 1. Until there's a bigger number, it's going to stay number 1. So now what we're going to do is we're going to go through and we're going to tell it how to check if it has a bigger number. So when it does the check to see what the next number is, which by the way, we're actually going to change this to a 1, since we've already established 0, so we're starting at number 1. That was my own little not thinking far enough ahead. So we're going to see we actually have to establish another variable, integer x another placeholder for x equals 0, x is less than get list length count ranked x equals x plus 1. Now we are going to see if the new entry that came up that shows up in check, which the first time this runs, that will check list entry number 1, or in human speak, the second entry, because computer lists start at 0. If check is a bigger or a smaller number than that first entry. So if check is greater than cast as integer list to string, because everything in a list is a string, so we're breaking down that entire list of strings to pull out a single string, list to string, count ranked, establishing the list, and X to establish which one we're looking at. Now what we need to be able to do is to insert the specific thing inside that list at the space that it has just earned. If it is, in fact, a bigger number than the one it just checked, then it's going to take that space. It's going to take the space where X is, and it's going to bump the rest of the list down. So that's what we need to look up. LSL, insert item to list. There it is, list insert list. Returns a list that contains all the elements from the destination, but with the elements from the source inserted at position start. This is exactly what we need to do. They already have a function for it. How wonderfully convenient. So we'll copy, close Google. We'll bring that down. It's only going to be one command, but this makes it easier to put in there. So, list destination, that will be count ranked. List source, we have to format it as a list, even though it's only going to have one entry, and that is going to be check. Integer start will equal X. That inserts that right there. We're also going to have to put the name in. So list destination, visit ranked, X. So we're going to get the entry for the name by looking back up to the original for list, and it's integer I, because that is going to be which entry on the visit list we're doing. So that will be list to string visit I. That will go ahead and insert those names into place. Now the thing is, if this never finds that it is larger than the number ahead of it, it will never enter it in. We need to make sure that it will. So we're going to set up a simple toggle flag. Integer low equals true. Low equals false. And at the conclusion of that for statement, if low count ranked equals count ranked plus check visit ranked equals visit ranked plus I had that wrong there. Wrong kind of. I did a wrong thing on that. Not as wrong as I thought it was. There we go. I had to put I made a mistake. I did not put the closing parentheses here. I had only had the closing bracket for the list section. Now that will actually process incorrectly. But back to here. Count ranked equals count ranked plus check. Visit ranked equals visit ranked plus there. And then when it reiterates the for loop back up to here, is will automatically turn the low flag back on. It will get the next check. It will inform the person working at it what that number is if debug is turned on. And it will then run the for loop, which will check to see is check higher than any of the entries in ranked. If it's equal to, it will just keep right on going. So if you had two of them that were, say, set at 22 visits, then it will automatically put the new one after the previous one. It doesn't really matter what order they're in if the numbers are the same, because you're only ranking by the number of logged visits or the number of logged appearances, because you can have multiple logged appearances within one visit. And if it finds a place to insert it, it turns off the low flag, so that it will come all the way down here to process if low as part of this for statement. If this is turned off, it won't do this. If it never found a spot to put it, then it will run this code. And that should automatically iterate through each cycle. So let's give that a test. All right, we have partial success. We have, it did in fact run each of these checks. It then properly placed the first two in correct order. Except I do not actually see. There's something I'm not seeing in there. We have an error. Let's figure out why. Alright, it does in fact have pin logged 23 times, which it should, but that didn't show up there. The reason it didn't show up on that particular list, and we can fix that, is because we jumped ahead of it. So remember, when it is showing you the checking list item, that is part of the for statement under debug, checking list item. But since we skipped past the first one, since we automatically put them in the list, it did not correctly add that in. So we can easily fix that by adding an occurrence of the debug line above here. So if we take the start of the integer back to 0, it's set at 1 during the for loop, so that will automatically just set everything for that correctly, except that it does not include check because check is established down here. So copy that up here. And actually, we could just simplify this. There we go. Checking list item 1 equals, just simplifies that whole thing. So that will solve one little problem. Now it actually does show us all of the entries. Now to figure out why did it place Jack at 5, it placed that correctly, but then it does not place 8 or any of the others. Let's see if we can figure out why. What did I do wrong? Bonus points if you figured it out before I did, because I do not know right now what I did wrong. Get list length visit, so it did go through, since that code to display the numbers it's checking ran every time. That means that the for loop that contains the rest of this did correctly implement its part. So that means the problem lies in the code to place the numbers in order. Somewhere in there is a problem. A way to check that would be to add another if debug down here, and just put out the list of, we really should be fine with just the count. So LL owner say string count ranked. This is not going to be the most pleasant thing to look at, but it will give us some idea. All right, it checks list item number 1 normally. Then we're into the actual for loop. Checking list item 2 equals 5, so that's 23 and 5. It's just simply not incrementing it into the list at all, which we already saw, but so why would it not be in the list? Let me figure it out and I will start up the recording again. Okay, as much as I honestly really hate to do this particular problem is not quite coming together. I'm not sure what's holding it up from actually inserting the additional entries after the first one gets added. And I have a couple of ideas how to fix it, but this video is already hitting 40 minutes long, and that means it's going to take a long time to render. So I'm going to have to finish solving this particular problem in next week's episode. So my apologies for the delay there. Just take it to mean that you all are finally pushing my skills to the point that I don't know all the answers off the top of my head. I actually had a couple points I cut this to go back and explain things differently because I adjusted something midstream. So I think I will definitely be able to get this fixed, and I really hate leaving this on an incomplete note, but unfortunately, if I don't do that, I may run out of time rendering it. I don't think y'all realize just the initial render where I take Fraps's raw footage, I then take it into my editing program and do one cycle where I just turn it into a more compressed file format. This actually makes every other step run dramatically easier, because if I try to run all the different stuff through my editing program on the uncompressed files, I wind up having a real bear trying to do that. So, but that one process alone is probably going to take me 3 hours just to get that run. And I've got a fairly beefy machine. It's just video rendering, for those of you who haven't done it, it really is a drain on your system. So I'm going to get this rendering, and I will come back to figuring out what's wrong with this. So apologies for the incomplete video. I will go ahead and get this resolved, but that's going to be next week. So until then, this has been your Coder Kitty. Good night, good luck, happy coding. Meow.